I'm moving very slow. And that's not even what I want. Okay. Sorry, this is not what I want because I can't write on that. Oh. All right, I'm just going to use what you guys have. Here we go. This is what I can write on. Draw. Okay, so the table, I asked you to do 3 tables. Here's table 1, x and y1. You were asked to use what? 0, what was it? 1, 4, 9, 16. Cool. Output, what did you guys come up with? 0, 1, 2, 3, 4. Good. Then I said on table 2, I gave you the y's or x on this one? Y. So 0, 1, 2, 3, 4. Then you found the x on your own, right? Yes. What did you find? 0.5, 2. I'm going to write half. Is that okay with us? Yeah. Okay. And then what was this one? 2. 2? 4.5. So can I write 9 over 2? Okay. And then this one? 8. Okay. Then you will also asked to do 3 tables, which I'm going to move it over here because that big old number right there is in the way. Okay. And again, I'm assuming I give you 0, 1, 2, 3, 4, right? And your y values were, your x value were 0, 2, 18, and 32. Okay. Beautiful. Yes. So, look at this. You were giving 3 equations, okay? So let's look at the first equation. This first equation right here, can we all agree that's just y equals square root of x? Can we call this the parent function? Is that the parent function? How do we know it's a parent function? How do we know? No transformation. No transformation. Nothing is with it, okay? Parents are pretty boring. We're pretty plain, think of it that way, okay? So if you see a boring function with no transformation, that's a parent. Okay. Now, how is that different from y2? How is y2 different from the parent? What's in y2, Thomas?
Horizontal compression 2.
But what is in y2 that's different, the equation itself, before we go to the table? The equation itself. What's in the equation of y2? There is, right? There's a coefficient of what? Of 2. So now check out the values on the table then. What's going on with these values in comparison to those?
They're half.
They are half. So what can we say about y2 comparison that to the parent? Okay. Is it getting bigger or smaller? It is getting smaller, but how much smaller? Half the size, right? So when things get smaller in mathematics, do we call it stretch or do we call that compression? Compress or compression, right? So it's compressed. Well, compressed by how much?
2.
Can you say compressed by a 2? Can you say compressed by a half? And a third? Yeah. So when you're using the word compress or compression, you want it to be less than what? Less than 1, right? So we're saying that y2 is a compression. But now, is it compressing the x or the y value? X. Look, the y value is still the same, right? So it's making the x value smaller by a half. But remember, the leading coefficient is what? It's what? 2. But it's making it smaller by a half. So in essence, what we're doing it's compressing by a half because we need to take its reciprocal. Does that make sense so far? Now let's compare y3 to the parent. What's the different here to the parent? The leading coefficient now is what? A half. Okay, but now look at the table. What is up with the table? A double. So what happened when you flip the half? When you flip the half, what number do you get? You get a 2, right? So now look at the table. It's bigger. So is that a stretch or is that compressed? It is. It's a stretch by how much? Double. So how many times?
2.
2 times. Okay, so that's really the terminology. So when you see in the x or with the x, if it's ever a number with it, then you need to flip it first and then decide. Okay, it's a stretch if it's greater than what unit? 1. If it's compressed, if it's between 0 and 1. Does that make sense so far? So that now we are going to define, yes, Karen? I'm not flipping the fraction. I'm just looking at the table and then come up with like a rule of thumb, really, right? So look at this table. I'm going to circle it real quick. See this table right here? Oh, 2.9. See this table right here, Karen? Right? And this parent table. Can you see that? Would you agree that the x value on this table is half the size? The x value, right? Okay. Now look at the y, look at the equation. What number do you see in it? Right. So the rule of thumb is, right? The rule of thumb. So we're kind of, as a student and as a teacher, you want to come up with something that you can remember. Would you agree? So what do you think, how would I connect these two together? So, remember, you just said that the x value is how much smaller? Good. What number do you see in here? So how are they related? Can you just take the 2 and flip it? Okay. Now let's look at table 3, okay, to see if that rule will work. Look at table 3. Can you see this here? Can you tell me what's going on with the x value to the parent? Good. Now let's take that table, go back to the equation. What number do you see in the equation? Good. How are those, what do you think is going to happen? Right. So that's why, not because, you know what I mean? So when you see a pattern, you want to come up with something or a saying that will help you remember. Okay? Any questions so far with that? All right, so now we're going to write a rule, okay? But before I do that, can you do me a favor and sketch it out on that little grid right there? Okay, all 3 graphs. Label it which one's y1, which one's y2, which one's y3, because you already have the dots. So just plot the dots, okay? So you have a grid. Graph it out for me. Label y1, y2, y3, or if you have different colors, that's even better. Do you think these are straight lines? Are these straight lines?
No.
No, so be very careful, okay? Raise your hand if you guys have already studied horizontal compresses and stretch in Algebra 2 or Algebra 3 trade. Oh, okay. Quite a few of you. Okay. Then this is like review, but if you didn't, this was meant to be a brand new thing for you. Okay. Do you guys have like an eyebrow shape off of these curves? Yeah. Okay. Radicals will always be like an eyebrow shape. Are we ready to fill out the argument? Okay. So if the argument x, which is the input, okay, of this particular function, of function f, is y equals f of x. Very fancy notations here. So if the argument x of a function f, okay, is y equals f of x, is multiplied by a positive number, let's call it a. So a is positive or negative?
Positive.
Positive, okay. The graph of a new function, can you see how it changes from f, y equals f of x to now this? Right? Can you see now instead of x before, now you have a times x? Because that's what it says. It's going to multiply by a, okay? So the graph of the new function, f equals f of a, is obtained by, so multiplying okay. Now I'm really going to ask you with this. Look at y1 and y2, okay? y1 is the parent. What is the a value in y2? 2, great. But when we went to the table, did we multiply by 2? No, what did we do? We multiply by?
It's reciprocal.
Right, that is correct. That's what I'm really trying to get, okay? So by multiplying each x coordinate, okay, by parentheses a or quotation a or 1 over a. Remember, let's look at the y2 table. Equation 2, we just all mentioned that a equals 2, right, class?
Yes.
But when we went here, how did we get this? We multiply by a, by 2, or 1 over a, which is 1/2.
1 over a.
1 over a. So that's why we're flipping, okay? All right, now we're going to have math words coming up. It is horizontally compressing. Compressing if a is greater than 1 or less than 1. When does it get smaller according to the 3 tables that we have? Okay, so let's look at the tables again, right? The parent function is this one, right, class? And then these are the 2 transformations. The a on the second table, is that greater than 1 or less than 1?
Greater.
Second table, second equation. Let's talk about just the a value. What's the a value?
Greater.
Greater than, right? Did the x value get bigger or smaller?
Smaller.
Right? So, when we do the math, then we multiply by 1 over a. Can we agree? But when we say, hey, is that a horizontal compress or is that a horizontal stretch? Then we're going to say that, hey, it's a horizontal compress if a is greater than 1, right? Because on the second equation, a was 2 and your values were half the size, okay? Now, it is horizontally stretched. If, what about if? If a is in between what? 0 and 1, right? Like 1/2, 1/3, 1/4, and so on and so on. Okay. And then I'm going to take a break right here. This is all we're going to do today. You can talk to your peeps.